Hey guys, welcome back to AlgoYogi. We are now doing stack series, and our next problem in the list is daily temperatures. Let's go to LeetCode and give it a read. Given an array of integers, temperatures represents the daily temperatures. Now we need to return an array answer such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, we'll keep the answer as 0 instead. So as we are given temperatures here, this is what represents answer, and where each number element or integer represents the number of days you have to wait to get the next warmer day, and this is the order we will be following. So what this problem is really asking us to create an answer array which will be of same size as my temperatures. We will be calculating the number of days we need to wait to get a warmer temperature. So if you see current day 73 right here, what is the next greater temperature? It's right next to 73. So if I do proper indexing right here, sorry about this. So if I just index them 0, 1, 2, 3, 4, 5, 6, and 7. So there are 8 days temperature that's given to us. Now, so 73, my current ith, which is basically 0, needs to wait 1 day to get the next warmer temperature. So I'll be basically saving 1 right here. Then let's calculate the answer for 74, which is index 1. How many days do I need to wait to get a next greater temperature, which this is also 1. How about 75? Well, 75 needs to actually wait. 71 is not greater than 75. 69 is not greater than 75. This is also not greater than 75. This is. So basically it has to wait 1, 2, 3, and 4 days to get a warmer temperature. How about 71? It had to wait 2 days. How about 69? Just 1 day. How about 72? 72 is seeing just right after 1 day, which is 76. How about 76? Well, this does not have any temperature to its right that is greater than 76. This is actually might be the greatest of all these temperatures. So we will put a 0 here. That was asked in the problem. And then for 73 also, since there is no any other day next to 73, then it will be also a 0. So one of the ways would be just basically following this brute force approach that we just did right here. That would be the brute force approach. But and it will be of big of n time complexity, because for each temperature, for each day we are basically trying to looking for a greater temperature, right? That's what we just did for each of them. We were just trying to find a greater temperature. Like for this, we found over here. For 71, we found over 72. So this will be of big of n square time complexity. Can we do better? Yes, we can. How are we going to do it? We're going to use stack to basically track of greater temperature seen before, and we are going to do it. We're going to do it in reverse order. We will be basically calculating. I'm going to calculate this answer again, so I'll just take it away right from here, and as we follow stack right here, this will be my stack where I will be storing the indexes of the temperature from the iterating my temperatures from the back to the front. And the reason is because I will know what temperatures that I have seen, and I will be able to access those temperatures using the index. So I will be actually storing into my stack the integers the indexes. So what I'll have here, I will again calculate my answer. Initially, I'll just initialize all of them to 0. And the reason is so that I can actually store the answers using the indexes. So that will basically be of same size as temperatures. Now I'm following my temperatures from back to the front. All right, so what I do is I'll have this condition, so while, so let's go ahead and just iterate over our temperatures. So I see 73. For 73, since there is nothing in my stack, that means I have not seen any greater temperature than 73. So what I'll do is I'll move on to my next. But before that, I will put 73 or 7 as index, so that I could access 73 using index 7 to basically check for next or a temperature that I'm going to be calculating the next warmer day 4. So I'll be calculating it for 76, so that I'll be able to check what was the top of my stack. And initially you can see for 76 the top of my stack is 7 index, which is 73. So I'll have a condition while stack, so there is something in stack, and stack stop will be basically, we can find it out by temperature and sorry, my bad here. So it will be outside, so I can find out the temperature while stack, and stack stop is the index of the last temperature that I just saw, or all the temperature that I've seen and I have appended to my stack, so I can access this. So this will give me 73 for now, and I'll check if this is smaller than, if this value is smaller than my current temp, which is so I'll just call this temps. Okay, so I'll just call this temps, and this is temps, so that when I reference temp, that means I'm referring a particular one temperature from the back, because I'm going from back to the front. Okay, all right, so if this is the condition, that means what? That means I saw the temperature that I have stored in my stack that was smaller than my current temperature. So I'll be popping this, so that the reason I'm popping it, so that I can actually keep going down to my stack to see what all temperature that I've stored, and is there a temperature that is actually greater than my current temperature. So in this case, stack is empty. So what I'll do is if stack, otherwise in this case I'll just do stack.pop. If stack was not empty after following this loop, that means I have seen a temperature that's actually greater than my current temperature. So what I'll do is I'll append that to my answer. So answer I would be or I'll say the index that I saw must have been the top of the stack. So stack stop will give me the topmost index, and I can again see that you can't see this, so I'll just write it little over here. So I'll just store the answer I as stack top minus current I plus 1. So that's the number of days I have actually I'm gonna wait to see a warmer temperature. In this case, well, this will remain 0. Since my stack just got empty and we have popped out everything because we couldn't find anything greater than 76. All right, let's move on to 72. At 72, I will again go into checking stack has something. Or by the way, before we move out here, I will push that temperature to my stack, because this could be a potential warmer temperature for my previous temperatures, like the temperature that I've seen before. So seen before, I mean they might be present in the front. Okay, although I'm traversing it from back to front. So 72 now can see that stack is not empty because stack right now has 76. And by the way, this was safe to pop out because the only reason I'm popping it out because I'm seeing 76. 76 is greater than 73, so it's safe to pop out 73 so that 76 could cover, and it appears before, so it will be able to cover up for all the 73 values. But basically, if 73 was greater than any other temperature that occurred before it, 76 will be even greater. So 76 can safely we can safely pop out 73. So now 76 is on the top of the stack. For 72, you can check this particular condition does not execute. We come here, we come over here, stack is basically now is not empty. So what we'll calculate the answer? We'll calculate the answer by basically stack top. It shouldn't have been 76. It should have been the index, by the way, which is 6. So 6 minus I is 5. So 6 minus 5 is 1 actually. And my bad here. We are able to calculate it perfectly. We don't have to add one more because we are waiting 1 day. We're not calculating the number of values. So it's just 1. 6 minus 5 is 1. We will append 1 to my answer right here. So this will become 1 now. Okay, so this will be 1. Let's do it for 79. And by the way, we will push this on the top of my stack for 72. Let's calculate for 69. For 69, 72. Now this condition did not satisfy, so we'll come out. Stack is not empty. We'll calculate again. This will also become 1. For 71, we will basically check the top of this stack is not empty, and we must have pushed 69, or let's just push the index. So stack is not empty. Temperature on the top, which is basically 4th index, 69 is actually smaller than temperature, current temperature. So this condition satisfies. So what I'll do is I'll pop this index from the stack, and then 72 is not greater, so we'll come here. Stack is not empty. Now the index on the top is 5 minus 3, so this will be 5 minus 3. I'm calculating for this. 5 minus 3 is 2, so I'll append that to my answer right here. It will be 2. So it's gonna wait 2 days to see this temperature. So now we know what we need to do. We're going through. We'll keep going through all these values, and I think this logic definitely satisfies. It's taking too long, so I'll just leave it here and basically okay, let's just do it. For this 75, it will actually be keep popping all of these until it reaches 6. So this will be able to pop 5 and reaches 6 temperature is 76, and it's greater than 75, so it will be basically 6 minus 4 days. So this will become 4. For this it will be 1, and for 73 it will be 1. So this is actually just like this answer we calculated using brute force. This will be of big of n time complexity and big of n space complexity, and this is definitely better than our brute force approach. So let's implement this solution, and I guess it's not super straightforward. It's really you must have done a lot of other stack problems where you approach the problems by reversing the array and then calculating the answer. All right, so we're going to have let's calculate the n, which is the length of the temperatures array. The reason I'm doing it is because it has some use. One of the uses is let's create answer array. Let's call it answer because they were asking us to create the answer array. Answer will be of same size as temperature. Then let's have stack. Initially it's going to be empty. Then we will run over our temperatures, but from in the reversed manner, like going from back to front. So this is the way you will be. So we are going from n-1 index to 0th index. This is exclusive. So and this represents the direction. All right, so what do we do now? As I said, we will have a condition where while stack is not empty and temperatures at ith, the one I'm calculating for, is actually greater, smaller than stack. Actually, it's if it is greater, not smaller. If it is greater than temperature at the stack top. So this means that current temperature is greater, so this will not qualify for being the warmer temperature. So I'll just pop it from stack. Either I came across a temperature that was actually greater and it was still on the top of the stacks. I'm accessing it through the top of the stacks index that I'll be just storing right here. So stack.append append the index, right? And if let's say if stack is actually not empty, that means I have found a temperature that was greater than my current temperature, so I can actually store the result as answer at ith index would be basically the top of this stack index, because that's the one that was greater than my current temperature. So top of the stack minus my current I. Basically that's like I'm calculating the number of days I'll have to wait to see a warmer temperature, and I just found the warmer temperature. I didn't pop out every single thing from stack. I just found some temperature that was greater than my temperature I, and I'm appending that to my answer. And not like appending, I'm just changing the value, because currently everything holds as 0, and which will basically I wouldn't have to worry if if stack got empty, because if stack got empty, that means that I couldn't find a temperature that was greater than my current temperature I was calculating, and I'm appending that to my stack, so that this could be used as a value to calculate to find out a warmer temperature for the other temperatures that are in front of, to the left of this current I. And then finally I can just return my answer. Okay, so I'm gonna zoom out. Yeah, and so now this looks pretty good. All right, let's run it on our examples and see if everything's good. Just a little typo, because that's not how we do it in Python. Awesome, let's submit it. Okay, there is just a little problem right here. This was supposed to be 3. Okay, and I think the reason is I'm going to pop it even if it is equal to the temperature, because it was considering those equal temperature as warmer temperature. That's not what we want. So I think initially in those cases that was not the case. So cool, like we were able to just find out that typo live. Yeah, I mean, debugging is just, that's how debugging should be. Okay, time complexity is big of n, and space complexity is going to be also big of n, because at most we could just keep storing all the temperatures on this stack. Now let's go back to AlgoYogi, mark this solved, and see you guys later in the next problem. Until then, bye bye.